This is a production of Cornell University.
Thanks again to the organizers. As Chase said, my name is George Stack. I'm starting my second year of my PhD in Larry Smart's lab studying hemp breeding and genetics. And today I'm going to be talking to you about one of our field trials last year looking at high cannabinoid hemp cultivars. I'll throw my pointer on here too. First, I kind of wanted to cover what hemp is because it's a relatively new crop. So as defined by the federal government, hemp is low THC cannabis sativa, specifically less than 0.3% THC. And within that umbrella, there are several market classes, including fiber hemp, which is grown in these dense stands and can be used to make things like clothing and rope. Also grain hemp, which is also grown in dense stands, produces these grain heads harvested with a combine, can be used for cooking and pressing for oil. And cannabinoid hemp. So cannabinoids are secondary metabolites that are produced in these glandular trichomes in the female inflorescences. They're fairly valuable and can be extracted, and you can buy them at places like Wegmans. So I want to kind of circle back and talk about this 0.3% THC threshold, because this is really important for growers. If their crop tests above this THC threshold, then all of their plants have to be destroyed, and it's essentially a complete loss. And this is a real problem, especially for these producers of high cannabinoid hemp. So that's what I'm going to be focusing on today, is growing high cannabinoid hemp and making sure that it's under this legal threshold. So last summer of 2019, we did a CBD cultivar evaluation trial. CBD is just one of the many cannabinoids produced by hemp plants. There were 30 cultivars replicated at 2 sites, planted in these raised bed plastic mulch systems, which is very common for CBD production. And before I kind of dig into what we found in our results, we're going to need to do a little kind of background on cannabis. We're going to do some biochemistry. Hopefully this isn't too painful for anyone. So this is the cannabinoid biosynthetic pathway. It starts up here with olive-tolic acid and GPP coming together to form CBGA. CBGA is the major precursor for most of the cannabinoids produced in hemp. Here you can see it can be produced or converted into THCA, CBDA, and CBCA by their respective enzymes. I'm going to focus on this little section right here. We're going to blow it up and look at this CBDA synthase enzyme. And it looks like it converts CBGA exclusively into CBDA. And while that's mostly true, most of the CBGA is converted into CBDA. A small fraction is also converted into THCA. And that becomes problematic for high cannabinoid hemp production, specifically high CBD hemp production, and staying under that THC threshold. So that was our foray into biochemistry, and now we're going to do a little foray into genetics. We're going to talk about the B locus, which is a site in the cannabis genome that's very important for cannabinoid production. So it turns out that both the CBDA synthase and THCA synthase genes are located in the B locus, but they're almost never found linked together. In fact, they're what is called linked in repulsion. And that's because the rest of this B locus it's very messy. It has a lot of repeated sequences, transposons, pseudogenes, and there's a very low recombination rate. So you can't get recombination between these 2 genes. So even though they're at different sites in the genome, they behave essentially like alleles. And people have named them. They call the CBD type allele the BD allele, and the THC type allele the BT allele. And most hemp is diploid, so you can imagine there's 3 different ways that we can have these 2 alleles. You could have 2 of the BT alleles, you could have 1 of each allele, or you could have 2 CBD type alleles. And we call these 3 different states, we give them kind of special names: chemotype 1 for producing mostly THC, chemotype 2 for producing this 2-to-1 ratio of CBD to THC, and chemotype 3 for mostly CBD production. And when you look at this graphically, you can see these 3 groups kind of cluster out with the high THC types up here, this 2-to-1 ratio right here, and the mostly CBD type over here. But there's a little bit of a problem. So this red line here is the 0.3% THC threshold. And you'll see that some of the CBD types, as they accumulate more CBD, actually exceed that THC threshold. So, hold on to that. We'll come back to it. But you can imagine if we're trying to produce CBD as we are in this CBD cultivar trial, we'd want all of our individuals to be this chemotype 3, mostly CBD group. But it turns out when you get cultivars from commercial producers, that's not always the case. So at least 7 of the 30 cultivars that we had in our trial last year were not all chemotype 3. And so we saw things like this. So this is one cultivar that had chemotype 1, chemotype 2, and chemotype 3 individuals in it. And you can see that the chemotype 1 and 2 individuals are producing a lot of THC as a proportion of their total cannabinoids. And that's a real problem for growers, because these plants are not going to be compliant with that legal threshold, and then their crop is going to have to be destroyed. So I'm going to start a running tally here of some considerations for staying THC compliant when you're growing hemp for CBD. And our first consideration is you want chemotype 3 plants. You want these high CBD plants that do not accumulate a lot of THC. So the next thing that we looked at is how cannabinoids are accumulated in the plant over the course of the growing season. So we did a time series of shoot tip sampling on all of our cultivars. Here you see CBD percent, one of the cannabinoids we measured, and all of the curves are stacked based on when the cultivars started flowering. And you can see that most of them begin this kind of rapid increase in concentration of cannabinoids in the weeks immediately following terminal flowering. And that makes sense because most of the cannabinoids are concentrated in the female inflorescences. There's some variation, but most of them start this kind of rapid increase. But what's really interesting is when you compare this graph that has total potential CBD on the y-axis here to the graph with total potential THC on the y-axis here. And so I'll flip back and forth between these two slides a few times. And if you look closely, you can see that it's essentially the same trend for all the lines, but they're just at different scales. And that's because of the coupling of CBD and THC production by the CBDA synthase enzyme that we talked about earlier. And that becomes problematic when you look at THC and you add this legal threshold in here, because the cultivars that accumulated high levels of CBD also accumulated enough THC to be above that legal threshold. So it leaves you a very small window for doing regulatory testing and harvesting before you become not compliant. So we'll add a second consideration here for staying THC compliant is that you really want to do regular testing to make sure you're staying under that threshold. So I briefly mentioned in that last slide a little bit about flowering. So all of those curves were standardized based on flowering time. So let's look at flowering time by cultivar over the course of the season. So we've got our cultivars on the y-axis here. We've got our date on the x-axis here. This vertical line is when we planted, and you see a lot of variation. So some cultivars flowered almost immediately. They actually flowered in the greenhouse before we could transplant them. Some flowered in July, some flowered in August. Many flowered in early September, and one even flowered in October. And it turns out that that is a very good indicator of when these cultivars would end up exceeding that THC threshold. So you can see now that we've added the dates that they exceeded the THC threshold with these circle X's, about 1 to 3 weeks after they begin terminally flowering, many cultivars exceed the THC threshold. So our third consideration for staying THC compliant when growing for CBD is going to be monitoring flowering, because flowering is very strongly correlated with the increase in concentration of cannabinoids. Again, that makes sense because most of the cannabinoids are in the trichomes on the female flower. But the problem with using flowering as your only indicator is that it doesn't give you a lot of time in advance to make management decisions before you need to harvest the plants and do regulatory testing. So we wanted to explore if there was something that happened earlier in the growing season that could be an indicator of when flowering was eventually coming or when cannabinoid accumulation would begin. So we looked at the growth curves of all of our cultivars. So we measured height weekly, and this is just growth rate in centimeters per day on the y-axis, again, date on the x-axis. And you can start to see some kind of groups partitioning out here. So we did a statistical analysis called k-means clustering to break out these groups, and we ended up with 5 different groups. And the groups are kind of defined by, when they reached their maximum growth rate and how high that maximum growth rate is. So this is pretty cool and interesting, but we wanted to see if this date, the date that the cultivar reached the maximum growth rate, which is something that a grower could measure in the field, was a good indicator of when the plant would eventually flower. And so we'll go back to our kind of cultivar timeline here. Again, we have these bars, flowering time, we have the circle X's, THC threshold, and now we've added triangles for reaching maximum growth rate. And what we see is that it's very cultivar dependent. So some cultivars reach their maximum growth rate basically when they're flowering, and others it's over a month in advance. So if you want to use this as a management tool, you need to have a lot of prior information about your cultivars because it's very cultivar dependent. I added kind of, this fourth consideration, monitoring growth rate, with the caveat that it's very cultivar dependent. So to kind of wrap up here, let's go over the considerations that we've talked about today for staying THC compliant. First consideration, having chemotype 3 plants, having these mostly CBD accumulating plants. 2, we need to do regular testing because many plants, even chemotype 3 plants, will accumulate high levels of THC if you let them go too long. 3, we want to monitor flowering because flowering is very strongly correlated with cannabinoid accumulation. And 4, if you have the information on cultivar, monitoring growth rate could be an additional management tool. So I'll just say thank you to, again, the organizers. Thank you to everybody in the Smart Lab, the Rose Lab, the Viance Lab. These companies provided hemp cultivars for us gratis. Our funding sources, Ag and Markets and Pixis. Here's my contact info if you want to talk about hemp anytime. And I'd be happy to take questions. I think I have a couple minutes.
This has been a production of Cornell University, on the web at cornell.edu.